Hello. In today's lecture, let me explain how the differential equation given here is solved. Now, this is a differential equation of third order. Solving this differential equation means to find y. So, solving this differential equation means finding the value of y. Now, the value of y is given by a solution which consists of two parts. One is y is equal to complementary function plus particular integral. So it consists of two parts. One is complementary function and another one is particular integral. This complementary function is being found using the homogeneous equation of this. The homogeneous equation of this is d cube plus 1 of y is equal to 0. So I take that and I solve for a particular variable, then write the complementary function. Now, the auxiliary, we call it as auxiliary equation of 1 is m cubed plus 1 is equal to 0. So this is the auxiliary equation of this. If it is d cube plus 1, then the auxiliary equation of it is m cube plus 1 is equal to 0. Now let me factorize this using a cube plus b cube formula. So this gives only m plus 1 into m squared minus m plus 1 is equal to 0. Now since this is a cubic equation, there should be three roots for this. Now one of the roots is, so this means that m is equal to minus 1, or there should be two other roots available for this problem. That means here it is written as using the idea of the roots of a quadratic equation. Ax squared plus bx plus c is equal to 0 is x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Using the formula, identifying a as 1, b as minus 1 and c as 1, we get it as minus of minus 1 plus or minus b squared is this divided by 2a. 2a means 2 into 1. So this gives me the value as 1 divided by 2 plus I root 3 by 2, and another, and m is equal to half minus I root 3 by 2. So these are the two roots, and they are imaginary roots because minus 3 is an imaginary number which will be written as I into root 3. Now the imaginary numbers occur in pairs, therefore the roots are m is equal to minus 1, m is equal to x by half plus I root 3 by 2, m is equal to half minus I root 3 by 2. Now having found the roots of the equation, the complementary function is, now I write the complementary function here. The complementary function is c1 into e to the power of minus x plus, here you see that it is the real part is half, therefore it is e to the power of x by 2 or half of x, and within brackets it is c2, cos root 3 by 2, imaginary part number is root 3 by 2 of x plus c3 sine root 3 by 2 of x. Call this as your 1. Now therefore we are able to get the complementary function of this. How to find the complementary function? Take the homogeneous equation of this. This is, here it is d cube plus 1 means m cube plus 1. Factorize this using a cube plus b cube formula. You get this. Find the value of the m. That is, m or the roots. Three roots are available because it's a cubic equation. Having found, and you see that the imaginary numbers occur in pairs. Now the complementary function is given by c1 into e to the power of minus x plus e to the power of x by 2. This is a real part. into C2 into cos root 3 by 2 of x plus C3 sin root 3 by 2 of x. Note that it is a cubic equation, hence if you go for the solution of it, it will have 3. That means integrating, actually speaking integrating. So if you get the solution of it, then the solution must have 3 constants, arbitrary constants. C1, C2, C3. These values could be got using initial conditions. Let us not bother about all those things. Let us try to solve this. So first part of it is that we are able to get the complementary function of it. The second part is finding the value of particular integral. Let me do that now. See, particular integral I will write here. See, here also this I will take the above this. See, particular integral I will write. Particular integral. See, here I will write this as e to the power of minus x plus into 1 plus cos x by 2. You know why I write this? See, I told you that is, you must know that if you want, that is the second part, finding the particular integral is nothing but integrating the right hand side. When you are going for an integration of a circular function, you cannot have it as a square or a cubic circular function or a quadratic circular function. They got to be brought to a cos x, cos sin 2x, cos 3x, like that. That is a sum form. Then only you can integrate. Therefore, what I have done is that in the place of cos squared x by 2, I have used that formula. What is that? We know that, I will write it here. We know that cos x is equal to 2 cos square x by 2 minus 1. So this implies your cos square x by 2 is equal to 1 plus cos x by 2. So this is how I am getting this. Now you see that I can write this as e to the power of minus x by 2, 1 into this, plus e to the power of minus x cos x by 2. Now call this as pi1 and call this as pi2. Let us try to solve this. So integrate this with respect to this. So you see that pi1, this one divided by, I have forgotten to write this. This is dq plus 1, and here also it is dq plus 1, and here also dq plus 1. So particular integral is e to the power of minus x into 1 plus cos x by 2 divided by this one dq plus 1. So I split it as e to the, I will rewrite this as c. So this is equal to e to the power of minus x divided by 2 into dq plus 1 plus e to the power of minus x cos x divided by 2 into dq plus 1. So this I will call it as pi1 plus pi2. Now you see that I have got the first particular integral as e to the power of minus x divided by 2 into dq plus 1 plus e to the power of minus x cos x divided by this. Now solve this, integrate this and combine with this, you will get the solution of it. Now I will write here pi1 is equal to e to the power of minus x divided by 2 into dq plus 1. Now what I will do here is that I can write this, you can factorize this and write. So I will factorize this e to the power of minus x divided by 2 into d plus 1 d square minus d plus 1. So this is the factorization of this. So if you are going to integrate with e to the power of ax, if you are going to integrate e to the power of ax with respect to the denominator, the method of doing it is replace this d by minus 1, d squared by plus 1, d cubed by minus 1, like that it goes on. Now if you replace this d by minus 1, then minus 1 into plus 1 will be minus 1 plus 1 will be 0. But it should not become 0. You cannot get it as 0, in which case we will maneuver it in a different way. Now, but wherever it does not become 0, you apply that rule. So when you apply here, here it will be d square will be minus 1 plus 1. This will be your, I'll write here, e to the power of minus x 2 into d plus 1, 1. Then d is minus 1, minus into minus plus 1, plus 1, plus 1. So this will be equal to e to the power of minus x divided by 6 into, see, this is 3. 3 into 2 is 6. 6 into d plus 1. 6 into d plus 1. Now, if you apply d is equal to minus 1, it becomes 0. So here we cannot allow it to become 0 because the integral definitely exists. So this problem definitely exists. Therefore, what we have to do, the rule says that you apply the rule for e to the power of ax divided by d plus something, where this if you substitute, it will become 0. So use that rule. The rule says that it is x into e to the power of minus x. Using that rule, I mean that into 6 into 1, that is equal to x into e to the power of minus 6, this one. See, this is a rule that I am using here. If you this is, you will find as a theoretical rule that how it should be done. So I am using that rule and finding the value, nothing more than that. Okay, so I am getting the pi1 as x into e to the power of minus 6 minus x by 6. Now let me go for pi2. What is my pi2? pi2 is e to the power of minus x cos x by 2. Now you see that this is a combination of two functions. This is, one is exponential. Here it is 2 into d cube plus 1. Now this is composed of two functions, namely one is an exponential function, the other one is a circular function. So you have to integrate with respect to e to the power of minus x. You integrate e to the power of minus x with respect to the denominator and then start doing it. Now how to integrate? The rule says, see, what does the rule say? E to the power of minus x divided by 2 into d minus 1 whole cube plus 1 into cos x. So this is what the rule says. The rule says that wherever in the place or replace d by d plus a or minus a, as a is the coefficient of the exponential x in the e to the power of something. So e to the power of minus x. So what is the coefficient of there? It is minus 1. That is why I wrote it as 2 into d minus 1 whole cube plus 1 into cos x. So the integration with respect to the integration of e to the power of minus x with respect to the denominator is now over. Now what is that you get here? So this one you get it to be, e to the power of minus x divided by 2 into, if we expand this, d cubed minus 3d squared plus 3d, d cubed minus 3d squared plus 3d minus 1 plus 1. These two get cancelled. So what is that you get here? So you get e to the power of minus x divided by 2 into, I'll write it here, 2 into d, see it is d cubed here, it is minus 3d squared plus 3d. This is what I get. Now into cos x is here. Now I have to integrate this cos x with respect to the denominators. How to do that, I will explain now. See, I will rub off this place. So pi2. See, when you are going to integrate a circular function a cos, either circular or even a hyperbolic function, whatever it be. Cos x uh, hyperbolic function means we will deal it in a different way. But if it is a circular function like this, cos x or cos 2x or sin 2x or sin x like that, then what you have to do is replace this d squared by minus 1 d cube, okay, a cube, using a. It is not a minus 1, here it is 1, but if it is going to be a cos ax, then you have to replace the d squared by minus a squared. Okay, I'll explain this. If it is cos ax, if it is cos ax, then replace this d squared by minus a squared. And if it is cubed, d cube, you replace it by minus a into d. If it is d to the power of 4, you replace it by a square. I explain this. See, if cos ax or sin ax are there, replace d squared by minus a squared. D cubed by, it is minus a squared d. Then d to the power of 4 by a to the power of 4. It is plus here. So remember this rule that either it is a cos ax or sin ax, if you are going to integrate in this way, then d squared must be replaced by minus a squared, d cubed by minus a squared d, d to the power of 4, a to the power of 4. Remember this rule. Now in the place of a, here you have got minus 1. Here, a squared is minus 1. So what I will do here is, see, it is e to the power of minus, with respect to that it is over. So 2 into equal to your e to the power of minus x divided by 2 into, it is 2d plus 3 into cos x. So this is what you get. So pi2, if I simplify this, I will get this. Now, it is still not over, so you have to do the integration. The integration with respect to the denominator of cos x is still to be done. So what you have to do here is that when you are having of this type, now here you have got 2d plus 3, you have to, by the method of doing it, what you have to do is multiply this by the conjugate, its conjugate, divide it also by its, see, multiply this by its conjugate, and multiply the numerator also by the conjugate, so the value will not be altered. Then carry out the integration. So this is nothing but what? E to the power of minus x into 2 into 2d plus 3 into 2d minus 3 into, you multiply this by 2d minus 3 into cos x. So the value is not altered. Say 2d minus 3, 2d minus the value is not altered. So you see that it is e to the power of minus x divided by 2 into, this is of the form a plus b into a minus b formula. So this is equal to 4d squared minus 9. So 4d squared minus 1 into, it is 2d minus 3 into cos x. 2d minus 3 into cos x. Now, what is, now you apply the rule again. When you are going to you integrate this, replace this d squared by minus 1, and so that if you replace it by minus 1, it is minus 4, minus 9 is minus 13. So you will get it as e to the power of minus x divided by 2 into minus 13. Take this 2d inside. D means differentiation. D is nothing but, see, what is your d? D is d by dx. D is equal to d by differentiation with respect to x. So you differentiate this with respect to x, it is minus. So it is minus 2 sin x minus 3 cos x. So what do you get here now? So you get it as e to the power of minus x divided by 2x, 2 into minus 13 minus 2 sin x minus 3 cos x. So what is that you get here now? So you get pi2 as, see, pi2 See, e to the power of minus x. It is minus 26. Take this minus sign outside. Here take this minus sign outside. Into minus into 2 sin x plus 3 cos x. So the answer is e to the power of minus x divided by, because minus into minus is plus, cos x. You call this as. So we have got 1, the complementary function, 2 is our particular integral 1, and 3 is our particular integral 3. Therefore, I will rub off this. Therefore, the solution, the final solution, therefore, is y. What is your complementary function here? This is your complementary function. C1 into e to the power of minus x plus e to the power of x by 2 into C2 cos root 3 by 2 of x plus C3 sine root 3 by 2 of x. Then plus complementary function. First one is x into e to the power of minus 6 by 6. The second one is, here you have got plus 1 by 26 e to the power of minus x into within brackets 2 sin x plus 3 cos x. So this is your answer. So what is that ultimately that we have got? We have got the solution as y is equal to c1 e to the power of minus x plus a e to the power of x by 2 into c2 cos root 3 by 2 of x plus c3 sin root 3 by 2 of x plus this is particular integral 1 x into e to the power of minus x by 6 plus 1 by 26 into e to the power of minus x 2 sin x plus 3 cos x. Now this is the, now if the initial values are given, then we can find the values of C1, C2, C3, because I told you that if it's a cubic equation, there will be 3 unknown, 3 arbitrary constants, so you can get the value of this. Once this is God means, if you're going to differentiate 3 times and do, you will get plus 1. You see that you will ultimately end up with this. So we can go to this by doing that. So this is about the solving the differential equation.